This is an exponentials and logarithms question. Give it a go first. If you get stuck on anything, then just skip forward to see my hints to each part. So we're given the value of Bob's car, which is in pounds, and time is in years. So the value is 17,000 e to the minus 0.25 t plus 2,000 e to the minus 0.5 plus 500. And part A is asking us to find the value of the car when t is 0. So this actually should be pretty straightforward. We're just putting in t is equal to 0 into our equation. E to the power of 0 is just, should be a t there. E to the power of 0 is just 1. So this then just becomes v is equal to 17,000 plus 2,000 plus 500. And that'll be 19,500 pounds. Part B is where this question starts to get a bit trickier. So it's asking us to calculate the exact value of t when v is equal to 9,500. So we're setting our value equal to 9,500. And then I'm going to rearrange this. I'm going to bring the 9,500 to the left-hand side. So the reason I'm doing this is because this equation that we have here is a hidden quadratic. So you want to think about, how can I turn this into a quadratic? So when you bring the 9,500 over, it becomes minus 9,000. And to turn this into a quadratic, you have to use this rule that x to the power of ab is the same thing as x to the power of a all to the power of b. So think about how you can turn this into a quadratic. You want to be using this rule in there as well. So the first thing I do is just make things a bit easier, divide everything by 1,000. I'm going to change the order as well. So we get 2e to the power of minus 0.5t plus 17e to the minus 0.25t minus 9 is equal to 0. So if I were to let x equal to e to the power of minus 0.25t, if I square that, if I work out what x squared is, so e to the minus 0.25t, this is all squared, we can bring that power inside using this rule. And then this becomes e to the power of minus 0.5. You times this by 2, it becomes 0.5. So e to the minus 0.5 t. So we see that our equation here can then be rewritten as a quadratic. It can be rewritten as 2x squared plus 17x minus 9 is equal to 0. And then we can factorize that quadratic. And we end up with two solutions. We end up with x is equal to half and x is equal to minus 9. So remember that x is e to the minus 0.25t. So this is equal to a half. And it's also equal to minus 9. But we can't get a solution from minus 9. If we were to do ln of both sides of that equation, so ln of minus 9 would give us a math error. So then, and the reason for that, well, we can have a look at the graph of e to the power of minus x. E to the power of minus x looks something like this. I've drawn e to the minus x because, well, the minus 2.5 only stretches it horizontally, so it doesn't change what the graph approaches. So as x gets bigger and bigger, then the y-coordinate approaches 0. It won't dip beneath the x-axis, the graph that is, so we can't get negative values being outputted. So we just have this, e to the minus 0.25t is equal to a half. So then we can do ln of both sides of that equation. We end up with minus 0.25t is ln of a half. The ln and the e cancel as their inverse operations. And then we can, because we were trying to get an exact answer. So it says in the question, we want the exact value of t when v is equal to 9,500. I'm going to change the left-hand side into a fraction. So it becomes minus 1 over 4t is ln of a half. then it becomes a bit easier to rearrange. So times both sides by -4, and then t becomes -4 ln a half. And just to tidy things up, we can use the power law. We can bring the minus sign inside of the logarithm. So then this becomes 4 ln a half to the power of -1. Half is the same thing as 2 to the -1. So you multiply the two powers, and then you end up with just 2, or 2 to the 1, which is just 2. So this then just becomes 4 ln 2, and that is our answer for t. All right, on to part C. So part C says, find the rate at which the value of the car is decreasing at the instant when t is equal to 8. All right, so t is 8. Give your answer in pounds per year to the nearest pound. So the key word here, if you're not sure how to do this question, is the word rate. So whenever you're trying to work out the rate at which something changes, in A-level maths that usually means one thing. Think about what that one thing would be. Once you have an idea as to what it would be, apply that to this equation, and then you're just going to be putting in t is equal to 8. So whenever you see the word rate, that means you differentiate. So the rate at which something changes, that is what differentiating tells you. So we have the value of a car v as a function of time. If we work out dv dt, that tells us the rate at which the value of that car changes over time. So I'll just rewrite the equation. And then we need to remember that if we were to have something like y is equal to e to the power of, let's say, 2x, when we're differentiating exponentials, this becomes 2e to the power of 2x. So then if we're working out what dv dt is, so the thing that's multiplied by the t is what comes out. So then the minus 0.25 comes out. That gets multiplied by the 17,000. And then same thing with the minus 0.5, that comes out, gets multiplied by the 2,000. And the differential of 500 is just 0, as there's no t there. Simplify this, we end up with minus 4,250 e to the minus 0.25t minus 1,000 e to the minus 0.5t. And the question is asking us, what is the rate at which the value of the car is decreasing at the instant when t is 8? And if you look at the units, it wants it in pounds per year to the nearest pound. So if we were to simply put in t is equal to 8, would that give us pounds per year? Well, v is in pounds and t is in years. So then that's good. Then if we work out what dv dt is, that tells us the rate at which the value changes of the car in pounds per year. So put in 8, and then the value that we get out will be in the form that we want it to be in. It will be in pounds per year. So we now put in 8 into our equation. And we end up with minus 593 to the nearest pound. So then our answer would be, it decreases by £593 per year.